Hello students, and welcome to the final video of this lesson. In this lesson, we're going to apply the mean value theorem across a couple of problems, and we're really going to dive into it a little bit more when you have to jump through a few more hoops after applying the mean value theorem. So let's get started. So in our first problem here, we just want to explain why we can't apply the mean value theorem to this function. Because it's continuous, x to the 2/3, it's got like a little long s look to it. But why can't we apply the mean value on this function for the interval from -1 to 1? And so let's kind of like go through here. So I just stated it's continuous. So let's see if it's differentiable. And so if I take this derivative, I'm going to get f prime of x equals, bring the 2/3 down, x to the -1/3. And if I rewrite this, it's going to be 2/3 cube root of x. What you want to notice is that f prime of x is undefined at x equals 0. So since f prime of x is undefined at x equals 0, the function f of x is not differentiable over the entire interval from -1 to 1. Even if we just take out that one value, x equals 0, is not differentiable there. In fact, you get a vertical tangent. Therefore, the mean value theorem cannot be applied. You just want to keep in mind that, you know, it looks continuous. If you were to graph it on a calculator, it looks like, hey, I might be able to connect 2 points. But since we don't have that final derivative where it is differentiable everywhere, even if we take out a single value, then we cannot apply the mean value theorem. Now, if the interval were different, it might be able to get applied maybe from 1 to 10 or something like that, because it is continuous and differentiable on that interval. So now let's go into the second problem, and this is the one that's really gonna spend a lot of time on here. So let's find the equation of the tangent line to the graph of f of x equals 2x plus sine x plus 1 on the interval from 0 to pi at the point which is guaranteed by the mean value theorem. All right, so what do we need to turn in? Well, we need to find the equation of the tangent line. So I'm already thinking like that needs to be my final product, not a single value, but the final equation of the tangent line. Y minus y1 equals n times x minus x1, okay? And the 0 and pi are not going to be the x's that I'm going to be using, okay? So let's start with this where we find f prime of x. I'm gonna get 2 plus cosine x there. So what's the next thing that we do with this? Well, you need to find the average rate of change on 0 to pi. So that's gonna be, all right, so f of 0 minus f of pi over 0 minus pi. And so f of 0, I'm gonna get 2 times 0 plus sine of 0, sine of 0, 0 plus 1, I'm gonna get 1 minus f of pi, so that's 2 pi, so let me put that in parentheses, 2 pi plus sine of pi, which is 0 plus 1, so plus 1, so 2 pi plus 1 over negative pi. So if I distribute that negative in the numerator there, I'm going to get negative 2 pi minus 1. Those ones are going to cancel out. So I'm going to get negative 2 pi over negative pi. And then the negatives and the pi's are going to divide out. And so I'm just going to be left with 2. So what do we do to find that guaranteed value? Well, we take our derivative and we set it equal to the average rate of change, which is 2. So when is f prime of x going to equal 2? So 2 plus cosine of c equals 2. Subtract 2, so I'm going to get cosine of c equals 0. And c is going to be, well, inverse cosine of 0 on the interval from 0 to pi is going to get us pi over 2. But I'm not done. So I found the guaranteed value, but I still need to come back and I need to find that tangent line, okay? So what are the things that we always need for a tangent line equation? Well, we need the point of tangency. Well, we have that x value. We know that the x value that's guaranteed for us is pi over 2. So we need to find f of pi over 2 so we can find that y value. So I'm going to substitute that in. I'm going to get 2 pi over 2 plus sine of pi over 2 plus 1. So the 2's are going to divide out here. I'm going to get pi. Sine of pi over 2 is plus 1 and then plus 1, so I'm going to get plus 2 here. So pi plus 2. So that is the y value. That's my point of tangency. pi over 2, and then pi plus 2. Now let's find the slope of the tangent line. In order to do that, we need to find f prime of pi over 2. So f prime pi over 2, let's see, that's going to be 2 plus cosine of pi over 2. Cosine of pi over 2 is 0, so this is going to equal 2 for that slope. Now I have enough information to write the slope of my equation for my tangent line. So the equation for that is y minus y1, which is right here. We just found it, pi over 2, so that's the point of tangency. So y minus, and I'm just going to throw it in parentheses. I'm not even going to simplify anything here. Times the slope, so or equals the slope, so that's going to be 2 times my x minus the x value, which is pi over 2. So x minus pi over 2. And again, that right there is your final answer. You don't have to do any simplifying. You don't have to put it in any different form. That is okay. Just leave it. This is the equation for the slope of a tangent line. And so you just substitute in your points. You find the slope of the tangent line, but you do have to remember the mean value theorem. The average rate of change is equal to that derivative. There's a guaranteed point there, okay? So always go back to what is the mean value theorem. The instantaneous rate of change is equal to the average rate of change. So finding the average rate of change and then bang, finding where that equals the derivative. Of course, if any of these two problems confuse you, or if you're not sure about any of the steps that I made here, please reach out to me for some help. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.